Hi, I'm Tony from HuntPop Gaming. In my previous video I spoke to you about the collection service and how it can help you clean up your code. So I'm going to assume that you know what the collection service is and how to use it. If not, go back and watch my previous video, then come straight back here and we'll see how we can really supercharge your game development. With that done, let's look at the problem. I'm going to create a game. It's got many parts in it. Some are rising and falling parts and some are spinning or fading parts. I've even created some rising platforms that spin, and some spinning platforms that fade, and there's even one that combines all of the variations. Now often people will create a script that covers each one of these scenarios. So for example, someone will write a sliding script, then they'll write a fading script, then they'll write a script that combines sliding and fading, and then might write another script which combines sliding, fading and rising and falling. But we're not going to do that, because we're going to use the collection service and we're going to write our code so it only targets one particular action that we want to do. Then using the collection service, we're going to apply those actions to each individual part. Let's take a look at how it's done. I have 3 scripts here that I've already written the code for. I'll just talk you through what each one does. This first script accepts a part and causes it to fade in and out. Now notice here the method name is execute. And this is really important. All 3 module scripts have this execute method in it, and our calling script will be assuming that the execute method is there. So we pass the part, we then set the transparency increment, how long it's going to take to fade, and how long it'll wait before it restarts, and how much time there will be between each loop taking place. We then create an infinite loop, and inside that we create a for loop, where we set the transparency equal to 0 and say this for loop will finish when the transparency gets to 1. We then pass the increment that we want the transparency to increase by on each iteration. We do the same again, but going in the other direction. We then make the loop pause again before we start all over again. Notice that in this script I'm only interested in the transparency. In this next script I'm only interested in the spinning aspect of the component. So once again I have an execute method, we set our tween info, we then set how far we want the part to spin. In this case we want to spin it all the way around. We then create our animation and we play it. Finally is our move module. This also uses the tween service and it also has the execute function. Here we pass in a part and we get the X, Y and Z position of it. Once again an assumption's made that each part that's passed in has all these 3 attributes. But you could always do an additional check to say if this value doesn't exist, set the value to 0. That way you don't have to add attributes to the part if you feel you don't need to. We then set our start position and our end position, how long we want the slide to take place for and the wait time. Once again we set our tween info and the goal for the end position. We then create an animation and play it. These are the 3 scripts that enable us to have multiple moving parts moving in different directions. But to get the scripts working, we're going to need a component manager. The responsibility of the component manager is to load the components in so we can use them at runtime. So the first thing I do is create a load components module function. In here I add a loop, I get my components folder and iterate through all the children in there. I then check to make sure it's a module script. I've only put this check in just in case I add something in there in the future and I don't want to be changing the code at that time. I now get the name of the script and require that module. I then look for the function of execute and if it's in there, I add it to my table of components. Next I create a function to apply the code that I've created in the 3 module scripts to all the relevant parts that I've tagged in the workspace. But this time I'm going to iterate over all of the module scripts that were added in the previous step. Then what this does, it returns the name of the module script and the execute function. Next I use the collection service to get all the tagged items that match the name of the module script. It's worth noting that the name of the module scripts is a 1-to-1 match with the tags that I added in the tag editor. At this point I'll have all the parts from my workspace and I'll loop through each one, pass the part into the function of my module script. Finally, I cover the scenario where I might add a new part to the game and dynamically add a tag to it, and just expect this functionality to work. So here once again I call the collection service, I use the getInstantAdded signal, passing in the tag name, and now it's watching for something being added with that tag name. So I can apply the execute function by passing in the part. Finally in my component manager, I create an initialize function which calls the load component modules function and calls the apply component parts function, and then it calls initialize on it. The small amount of code that we've written here now allows you to mix and match what effects you want to apply to a particular part. Your options aren't limited to these 3 modules that I've created. Done right, you'll be able to build a library of different scripts that you can package up and use in different games. Ultimately, it'll increase the speed in which you develop. That's it for now. I'm Tony from Humpop Gaming, and I'll see you in the next one.